So let us look to adding a compute layer in the AWS solution architect. In this class, we are going to look to the architecture needs of the cafe because we just did for them a static website and we host it in Amazon S3. The next step for them is to expand this and create a dynamic website with a dynamic content in an EC2 instance and with the help of Elastic File System, which is a service for network storage that we will study in this class. So the cafe wants the website to display more than a static content to provide dynamic capabilities. They want to introduce online ordering for customers and enable the cafe staff to view submitted orders. So we want to look to add a compute instances with Amazon EC2. We know in AWS there is multiple compute choices that we can use. We can use a virtual machine like Amazon Elastic Compute Cloud, or even Amazon Lightsail. And Lightsail, guys, is pre-configured EC2 instance that suits a specific need. So for example, if you want to have an EC2 machine with WordPress pre-configured with everything, all you need to do is just to launch it and put the administrator details and the configuration. You can use Amazon Lightsail. A good example of that as well, if you want to build an online store, you can create a new instance using Amazon Lightsail with Magento, and Magento will be a pre-configured online store. So if you have an idea for an online store that you want to launch, what you can do is to create Amazon Lightsail with Magento, and you will configure it, upload all the product pictures, and you will have it ready in no time. We have also container services like Amazon Elastic Container Service, which enables us to run a Docker container on application AWS infrastructure. There is also a platform as a service for web development. For the guys who have a web application and they want just to deploy it, they can use Elastic Beanstalk, where Elastic Beanstalk will do the high scalability and the high availability of the system, and they can basically just monitor it, and it will provision all the resources that it needs to run a web application. In terms of serverless, we're including AWS Lambda, which is a serverless compute solution that runs Java, Go, PowerShell script, Node.js, C#, Python, or Ruby code. This also including AWS Fargate, which is a compute platform for containers. It is a cluster management system for Docker container. Even if you have a specialized project or you need a specialized solutions, AWS Outpost provides us with a way to run an AWS infrastructure and services on a prem data center. And you can also use AWS Patch, which is a service that runs patch jobs at any scale. So if you have number of instances that running on a premise data center and you want to do, for example, Windows Server update for all of them, you could use AWS Patch. When you select your AWS compute runtime for your workload, consider the virtual machines and container-based services, which can provide us with more control over our infrastructure. However, the degree of customization that we have is very good in terms of the foundational services. In an EC2, you can create a network, you can choose the storage level, you can create a VPC, and you put your EC2 instances on them. And the same story also applies to Elastic Container Service. But if you look to services like Fargate, where you have less access to control and to configuration of the infrastructure, but you have more or faster application deployment, you can look to AWS Fargate or AWS Lightsail and AWS Lambda. So this enables us to have a quick deployment. And those services in the specialized solutions address a specific type of workload or hybrid cloud and patching. These specialized services work well for these use cases because they are also fully managed by AWS. And we will focus now in studying Amazon EC2. Amazon EC2 provides us with a resizable compute capacity in the cloud. It is basically create a virtual machine, a server. We can provision those servers in a few minutes, and they can automatically scale capacity up or down as needed. It enables us to pay only for the capacity that we use. Now, most likely when you create an EC2, if it is run by operating system like Linux, you will pay per second. But for Windows operating system, you will pay per hour. So the differences between operating system will impact our choices when we select those compute instances. An Amazon EC2 instance run as a virtual machines on host computer that are located in one of the AWS availability zone. Each virtual machine runs an operating system such as Amazon Linux or Microsoft Windows, and you can install and run your application on the OS in each virtual machine. You can even run enterprise applications that span multiple virtual machines. The virtual machine run on top of a hypervisor that is maintained by AWS. Now, the hypervisor is the operating platform layer that provides us with virtualization. It is layer that provides us with the actual physical hardware resources that it needs to run, such as the processors and the memory and the storage. Some of those EC2 instances use also an instance store. Now, this is very important for the exam, guys. In instance store, also is known as ephemeral storage. It is a storage that is physically attached to the host computer and provides temporary block level storage to an instance. The shortcoming of instance store that if you stop the machine, the content of the volume will be wiped out. So the content of the volume are not persistent. So many EC2 instances use the instance store. So basically they store their data inside the EC2 instance itself, inside the actual hardware that was running under the hypervisor. So they put the data in the volume here. The problem with these, if you stop the EC2 instance, which is this guy here, the content of the instance store or the ephemeral storage will be totally wiped out. So the data here are not persistent, and you can change as well the type or the size of your EC2 instance, because in order to change the type, you need to stop the EC2 instance, so you will lose the content of the volume. Now, most people, and what is mostly recommended, is to use the EC2 instances backed by an elastic block storage, which is the block level storage service that we will use in order to boot the EC2 instance, and the content of the volume are persistent independently from the life cycle of the EC2. Even if you terminate the EC2, the data in the elastic block store, EBS, will be persistent. Also, you can use something called elastic block storage optimized instances, which provide us with faster access to an attached Amazon elastic block storage volume by minimizing the input-output connection between the volume and other traffic from the instances. EC2 instances can have a network connectivity to other resources, such as other EC2 instances, or even AWS services, and also the internet. You can configure the degree of networking access to suit your needs and to the balance of that accessibility and the security requirements. So to balance between the security requirements and the accessibility, you could use security group, as we will understand later on. Different instance types provide different levels of networking performance, and this is basically the selection of those instances is dependent in your business requirement and why you need those EC2 instances. Amazon EC2 provides virtual machines where you can host the same kinds of application that you might run on a traditional on-premises server, and the common use cases for EC2, including web server, application servers, database servers, and media servers. In particular, consider Amazon EC2 as a compute choice in situations where you need the following: a complete control of your computing resources, or option for optimizing your compute cost. So you select or you use EC2 if you want to control over the compute resources that you have, and you want access to the network layer, to the storage layer, and you want to basically manage everything yourself. The second option, if you want to control or optimize the cost or reduce the cost, you can use Amazon EC2 instances. Because as we will see later on with the costing model of EC2, you can create an on-demand instance. However, if that on-demand instances, the price is not suitable, you can create a saving plans, or you can reserve those instances for 1 or 3 years, and you will pay as installments or with all upfront or partial upfront. When you use a reserved instance, you are going to get about 75% discount from the on-demand price. So if the on-demand price costs you per hour 0.2 cents, that could be reduced to 0.025 cents. To create an EC2 instance, you must make key decisions regarding its configuration details and the main parameter that you must specify to launch a secure instance, including Amazon machine image, AMI, instance type, network placement and addressing, and also the assumed role and the user data. You also need to decide about the storage, security group, and the key pair that you will use in order to launch those instances. And in the following section, we are going to study each decision we need to take in order to launch an EC2 instance. So in the first step, we want to choose the AMI or Amazon machine image. AMI provides us with an image that we can launch and use them to launch an instance. You can specify a source of that AMI when you launch the instance, and those AMI includes a template for the root volume of the instance and the launch permissions, also the block device mappings. A root volume typically contains an operating system and everything that has been installed in that operating system, including applications, utilities, libraries, and so on. Amazon EC2 copies those templates to the root volume of the new instance and then starts it. The launch permissions control which AWS account can use the AMI to launch an instances, and they also enable you to make the AMI available to the public. The block device mapping specify additional storage volume, if any, or you need to attach to the instance when it is launched. You can also launch multiple instances from a single AMI when you need multiple instances that have the same configuration. You can also use different AMIs to launch instances when you need instances with different configurations. For example, you might have one AMI to implement web server instances in your architecture and another to implement application server instances. The benefits of AMI including repeatability, reusability, and recoverability. Those AMI enable us to be repeating and recreating an instance from the same AMI. So you have the full configuration and the content of an EC2 instances all saved into that template. It can be used repeatedly to launch multiple instances with efficiency and precision. And this is very useful, guys, when you have a large fleet of EC2 instances that need to be deployed in a production, in testing, and in dev environment as well. AMI also promote reusability because those instances that are launched from the same AMI are exact replicas of each other. Also facilitate recoverability. If an instance fails, you can replace it by launching a new instance from the same AMI that you used to launch the original instance. In addition, those AMI provide a way to back up a complete EC2 instance configuration, which you can use to launch a replacement instance if there is a failure. So choosing an AMI to launch an instance, your decision should be based on 5 key characteristics. The region, each AMI exists in a specific region, therefore you must select an AMI that is available in that region. Operating system, for an AMI that is provided by AWS, you can choose between Microsoft Windows or multiple variants of Linux operating system. The storage of the root device, and this is really important. All AMIs are classified either as Amazon Elastic Block Storage backed instances or instance store backed instances. The data on an instance store volume persists only during the lifetime of the instance, but the data on Elastic Block Storage volume persists independently of the life cycle of the instance. And finally, the architecture, because the architecture that you want to use basically define the type of a processor your architecture needs and the best fit for your workload. You can choose between 32-bit or 64-bit and either an x86 or ARM instruction set architecture. The next option is going to be the virtualization type. You can use one of 2 types of virtualization. You can use the para-virtualization or hardware virtualization machine. The main differences between the parallel virtualization and the hardware virtual machine include how they boot and whether they can take advantage of special hardware extensions for better performance. For the best performance, you can use an AMI with HVM virtualization type. You can obtain an AMI from one of 4 sources. The first one is the Quick Start, which are an AMI that are built by AWS. AWS also enables you to create your own AMI, and you will find them under the My AMI section. You can also look for AMI in the AWS Marketplace, and these offer a digital catalog that lists thousands of software solutions normally built by a third-party organization or a company, and you can use it out of the box. Maybe you want an AMI for machine learning or for deep learning, you can go to the marketplace and you going to buy it. Or maybe for security testing, for penetration testing, you will find many AMI in the marketplace. The last choice is the community-built AMI, which are created by users like us. So people can create a new AMI and they want to share it with the rest of the world using the community AMI tab. Now let us go back and make sure to understand the differences between instance store-backed and Amazon Elastic Block Storage-backed AMI. So in Amazon EC2 instances that use instance store, it takes longer to boot than Amazon EC2 instances that use Amazon Elastic Block Storage EBS. The maximum capacity of the root device of an instance that is backed by Amazon Elastic Block Storage is 16 terabytes. However, in instance store-backed instance, we only get 10 gigabytes. The ability to stop the instance, it is, as I said, it's totally independent in EBS-backed volume from the lifecycle of the EC2 instance, so you can stop, start at any time. Don't forget you can terminate the instance, because if you want to terminate, this means delete. In an instance store-backed instance, when you decide to stop the EC2, that basically going to delete the content of the volume. You can also change the instance type of an instance store-backed instance, and the cost of the EBS-backed instance, including EBS storage charges, and the cost of an instance store-backed instance, including Amazon S3 storage charges, also including the Amazon S3 storage costs, are usually cheaper. So it's much cheaper to get an instance store with ephemeral volume rather than to get Elastic Block Storage backed instance. However, in most of the challenges lab and the guided lab, you are advised, guys, even for the project, you are advised to use an Amazon Elastic Block Storage instance. So this shows the life cycle of an instance and highlights the extra action and the states that an Amazon Elastic Block Storage backed instance allow. So from an AMI, you can launch that AMI and it will go to a pending state, then to the running state. If you stop the EC2, this is only available in Elastic Block Storage backed instances. That instance could be stopped, and from the stopping state, you could also terminate it, or even you can start it again and then it will go to pending, running, and from the running state, you could go to shut it down and terminate. Remember, termination means deletion in AWS. However, we can study later on how you can change the stop behavior and the shutdown behavior. So you want the shutdown to be terminated or stopped, depending on your use cases. If you don't want to delete or terminate any EC2, and that EC2, if it is stopped, what you could do is to change the behavior of the EC2. So when you go from shutting down, you go to stop. You could create a new AMI, and once you create a new AMI based on the quick start, which are the pre-built AMI by Amazon EC2 instances, then you launch an EC2. You access the EC2 via remote desktop or via SSH session, install in it a couple of software. Now you want to create a new AMI, which contains all the software that you need. You can create a new AMI and it will appear under My AMI tab. Also, you can copy that AMI from one region to another. So all you need to do is to go to the EC2 instance console, and from there, select the AMI and select copy, then select the destination region where you want to copy this AMI to. There is also an EC2 Image Builder. And this is another way to create an AMI, which is very easy to use in AWS Management Console. EC2 Image Builder is an AWS service that simplifies the creation, maintenance, validation, sharing, deployment of Linux or Microsoft Windows images. It provides us with a simple graphical interface to produce AMIs for the use on AWS and to generate a VM machine for use on a premise. One of the benefits of using the EC2 Image Builder is that it enables you to create images with only the essential components, which can reduce your exposure to security issues and threats. Before you use your image in a production, you can use EC2 Image Builder to validate your image with tests that are provided by AWS or with your own tests. Finally, it provides us with version control for revisioning management. And this is how you can use the EC2 Image Builder to create an image. As you can see, you can create an image pipeline with EC2 Image Builder by using the AWS Management Console, or even by using the AWS CLI, or the Application Programming Interface API. When you use the Management Console, you will have a step-by-step wizard. Includes the following step: identify a source image to build your new image from, select building component software for installation or customization. So you can choose component like Python, or you can choose Node.js, and so on. In step 3, you will select the hardening test that should be run each time the image pipeline runs so that the image passes those security checks. And you can step 4, build a schedule or schedule the building to identify how often this pipeline should run and when. Finally, you define whether you want the image to be distributed to a selected region or to a specific regions.